Hey Internet, Gordon Young with PC World here with the second half of my look at the AMD Ryzen AI 300 series processor. We have a video on the channel already if you want to look at the performance numbers. I get into all the performance stuff until your eyeballs fall out in that video. So if you want to look at the performance, please go to that video. But today it's about power efficiency. It is also about the performance on these laptops, basically running on battery and power efficiency plugged into the wall, because that IC does matter as well. Interestingly, we'll check that out later. And also some very interesting data I've run across while doing setting up for this video and doing all the testing on these laptops. Let's click on to the next slide though, because let's get this rocket started, right? So these are the specs of the three laptops I'm looking at. The first is the ZenBook S16. It has a Ryzen AI 9 HX370. That's a 12-core Zen 5 base laptop. It is a lightweight laptop. I know you think it's a big laptop because it's 16 inches. It is not a gaming laptop by any stretch, not a primary gaming laptop anyway. And it is also very lightweight at 3.3 pounds with a small 65-watt processor. I would call this really a big Ultrabook, or maybe it's similar to Apple's MacBook M3 15. Basically, for those who want lighter, don't really need heavy duty performance for GPU, but still basically want a very lightweight laptop with a big screen. The second laptop is an Asus ZenBook 14 OLED, and that has Intel's current best Intel Core Ultra 7 155H. Yes, I know Lunar Lake is on the way. That's going to be the Ultra 200 series. We'll get there when we get there, but today that's all I got to look at is the Core Ultra 7 155H. In the ZenBook 14, and of course the last laptop is the 13.8-inch screen Microsoft Surface Laptop 7. That has a Snapdragon X Elite with the 12-core X1 E80 in it. Basically, it's mid to upper tier, I would say, of the Snapdragon X parts. It's quite a nice laptop. All of them have the same amount of memory and basically the same amount of storage, but the real key performance here today is really looking at the processor, because you want to know what's going to affect the efficiency here. The efficiency of the processor makes a big difference in laptop battery life. The second one is the size of the battery. Basically, the battery is the gas tank on your car. The bigger the bigger the battery, the bigger gas tank, you can go further no matter what. So we have a 78 watt-hour battery in the ZenBook 16. We have a 75 watt-hour spec battery in the ZenBook 14, and we have a 54 watt-hour battery in the Microsoft Surface Laptop 7. The other thing that matters as well is a screen, because the screen does matter. The technology matters. Even the size can actually potentially matter here. And we have a 16-inch OLED panel in the S16. We have, that's the ZenBook S16. We have a 14-inch OLED in the ZenBook 14 OLED. And we have a 13.8-inch IPS panel in the Microsoft Surface Laptop. So I would say those are the three key movers of battery life. Yes, maybe RAM selection and clocks could matter. Storage can also matter quite a bit as well, but we're going to just sort of pretend it's not going to make that much of a difference today. But I still think really it comes down to battery capacity, screen, and processor are going to be 80% of the game here. So let's move on though. First benchmark chart. Yes, I know we weren't going to talk about performance, but this is actually the chart from our previous video as well. But I just want to recap basically how it stood, because I did a bunch of performance testing, and then I did do one battery test. This is UL Procyon Office. It uses Word, Excel, PowerPoint, and Outlook to basically run through several scripts. Very realistic workloads. If you actually watch it, it looks like somebody's actually using Office. It actually has all four of the apps open at the same time, and it alt tabs between the four open apps while the screen is on. The winner was the Surface Laptop 7 with the Snapdragon X Elite. In second place, although I would say it's pretty much a tie, is a Asus ZenBook S16 with that Ryzen AI 9 HX370 in it. And basically again, tie the ZenBook 14 OLED with the Core Ultra 755. But basically, both the x86 chips give you just over 10 hours, and the Snapdragon, the ARM-based chip, was giving you basically almost 2 hours more capacity or runtime in this rundown test. And yes, the other thing that really does matter again is the battery capacity, because you're looking at 78 watt hours for that S16 ZenBook. You're looking at 75 watt hours in that ZenBook 14 OLED. And basically, that's basically almost 40% plus larger batteries in both those laptops. But of course, the other key differentiator are the OLED panels. And I'm going to get into that because there's going to be a slide that probably is going to open your eyes on the difference between an IPS panel and OLED in this video. If you want to see one thing that's going to shock you, you're probably going to want to see that slide. But this is old information here. This is actually in the other video that is on the channel already. Let's keep going. This is new info. This is looking only at the SoC package power of the Ryzen AI 9 versus an older Ryzen 9 7940HS chip. That is basically a chip rated for 35 watt hours to 54 watt hours versus the 28 rated Ryzen AI 9 HX370 chip. Again, quite a bit difference in the power rating between the chips. Also, the Ryzen 9 7940HS in the Razer Blade 14 I tested is pretty much a content creation or a gaming laptop. It has a GeForce RTX 4070 laptop GPU in it, so it's got quite a bit of power in it. And to power all that up, it also has a 230 watt power brick that is very, very heavy. For this, though, I'm able to use software instead of hardware to look at it. So we're using HW Info to log the package power of these chips. And as you can see, not a surprise, the Ryzen 7000 with those Zen 4 cores at 35 to 54 watt hours. I'm guessing it's set for 35 watt hours technically, is consuming about 75 watt hours in a Cinebench run 2024 run over the entire thing. The Ryzen AI 9 HX370 is actually down there at about 33 watts over the entire run. And of course, you're going, well, big deal, Gordon. I mean, I would expect a lower wattage SoC to consume less power. Big whoop-de-doo. Well, here's the thing. That red line is a little shorter because it actually finished doing that Cinebench 2024 run a little faster than that Razer Blade 14 with that Ryzen 9 7940HS. And the reason is the performance was a little bit better, because if you look at the score, the ZenBook S16 with that lower power Ryzen AI 9 HX370 is about 982. I mean, really, it's a tie for the most part with that Razer Blade 14 with that Ryzen 7940HS. But it is still actually faster despite, again, let's look back at this. It's using less power, right? That's a considerably less power only in the SoC package. That's not counting the panel. That's not counting the SSD. That's not counting the RAM, any of those stuff in the laptop, right? So I would say that is a quite impressive thing. Yes, it is 12 cores versus 8 cores. I get it. But still, you're looking at it, better performance, and while you're using significantly less power for that Ryzen AI 9 in that ZenBook S16. So that is something I looked at first. That's just an eye opener. It's a very interesting thumb sucking data point that I think everybody should keep in mind, because again, we're getting these big ultrabooks that can run with lighter weight content creation laptops, and that's pretty damn impressive. So let's keep going. The next chart is WebExpert 4. And this is basically a browser-based benchmark. I'm running this on Chrome 126, 127, basically the same thing. This is the total system power at the USB-C port. I'm not measuring at the wall before the power brick, so that would be measuring on the AC side. I'm actually measuring this after it's been converted to the DC power that the laptops can consume. The orange line is the Snapdragon. The blue line is the Intel Meteor Lake. And the red line is Ryzen AI 9. I know you're going, I can't see anything. This looks like you dropped a box of crayons and stomped on the floor with them. But for the most part, you can see a lot of these blue lines and red lines that are peaking up above that orange line. A lot of that concentration in the orange. But I'm just going to quickly blip through the 3 charts separated so you can see how these things look. First up is Meteor Lake, I hope, if I got the charts right. Oh, I did it right for once. Okay, so you can see, again, very Intel-like. Intel really likes to boost up, get off the boost, and drop down in power. And you can see basically it boosts up, drops down, boosts up, drops down, and very, very spiky things that I've seen in Intel for a very long time. Tiger Lake, going back before Tiger Lake. This is what Intel does. Very, very spiky. Again, look, you're looking at, they're boosting all the way up above. Remember, total system power, because it has a 65 watt hour power brick, but they're getting up to about 58 watts just peak, short momentarily peak. We're talking probably milliseconds here because this is 50 samples per second using the measurement methods tools that I'm using. So, very Intel-like. Next up is Snapdragon. Snapdragon's very well behaved, I would say. Again, you sort of see those peaks. Basically, WebExpert 4 is a lightly threaded benchmark running in the browser. It's the only thing I'm running. It just kind of blips up and down. But again, look at Intel. Very, very high peaks, dropping back down. But you can see that concentration is, averaging about 10 watts. I averaged out the score here, about 10 watts over the entire run. The Snapdragon X Elite, Snapdragon Elite X, I got that right, I don't know, is about 7 watts, so a little bit less power running WebExpert 4 for total system power consumed across this run. So they're averaging about 7 watts during the run. Let's look at AMD. So AMD, I would say, is about halfway because we're on the same scale here, 0 to 50 watts, 50, 50, right? I would say AMD's a little bit Intel-like. We're getting decent boost clocks, and consuming more power, but on average about 7.7 watts. So 10 watts for Meteor Lake, 7 watts for Snapdragon, 7.7 watts for Ryzen AI 9. Keep going, Gordon, keep going. You got a lot to get through. All right, and then of course, what does matter is the browsing performance in the end, because does it matter? Well, okay, the only thing I'm looking at, this is the performance chart from the previous review. Ignore Kraken, ignore speedometer. This is, again, browsing 126. Oh, I guess it was actually on Chrome 126. So you're basically looking at the 3 laptops running WebExpert on this benchmark, and the high score is the Ryzen AI 9 at 348. Not a huge win, but decent lead over Meteor Lake, which is second place at 326. Snapdragon is at 316. So the winner is Ryzen AI in actual performance, and looks like it's doing that at decently less power than Intel, a little bit more power than Snapdragon Qualcomm. All right, let's keep going. What's next? Next is a Cinebench 2024 run. Same methodology where I basically am measuring at the USB-C port, 50 samples per second. And this is again, what I do is I measure an all-core, multi-core, multi-thread run of Cinebench 2024. Red is AMD. Orange is Qualcomm Snapdragon. Blue is Intel Meteor Lake. And you can see that actually Meteor Lake does peak up a little higher, but it does drop down to a little bit less power overall. And Ryzen is using a little bit more power than Meteor Lake. And I would say it actually looks very, very close to Snapdragon X. And interestingly, you would think it would boost up to higher performance in the beginning, but it is very flat. And I've seen that from AMD in the past, where they generally don't seem to boost up to very high all-core loads at the beginning of the load. And I did average out the score here, the actual watts consumed, and they're pretty much using about the same power, although the Ryzen AI is about 46 watts, which is who cares. But overall, because it does finish it shorter, the ones that finish this shorter, you can see red, you can see orange, they finish it before that Meteor Lake, which is coming in last because it continues on and on. Let's dive in. So I actually restricted the scale so we can look a little bit closer at the performance of this running Cinebench and watts consumed, and you can get a little closer look at it. Again, AMD looks like it's tracking right along with Snapdragon, and again, the similar wattage consumed as is. Meteor Lake, again, 45 watts, but it is taking considerably longer to finish this Cinebench 2024 run, according to my test. Let's keep going. This is Cinebench 2024 single-threaded run. So we're running this same thing again, same methodology, measuring at the USB-C port, DC side. And the chip that is using the most power is Meteor Lake at about 28 watts. The Ryzen AI 300, 23 watts. Again, I hope I didn't misspeak there. 28 watts for Meteor Lake, 23 watts for Ryzen AI 300. So a little bit less power. 5 watts is really quite a bit. That'll get you more battery life, basically, if you run it. And again, this is running in the high performance mode on all of these laptops because this is all plugged into the wall performance. And the reason I did not do HW Info to measure, say, SoC power is it simply does not work on Snapdragon parts yet. So hopefully that'll come one day. And Snapdragon actually is the most efficient here, running best performance at 17 watts. So 17 watts versus 23 watts versus 28 watts. And this is single-threaded performance. Okay, I'm just going to throw in performance in single-threaded performance. And winner is Snapdragon. So we are consuming less power. Again, this is the power of that Qualcomm Snapdragon X Elite. Pretty damn good because they're consuming about 17 watts, yet they still have the highest performance against the Ryzen AI at 113, and the Meteor Lake is down there at 104. So winner here, Snapdragon X Elite. And again, consuming a significantly less power. Well, significant may be overstating it. Consuming quite a bit less power than the x86 parts in Cinebench 2024. Okay, up next is what I'm calling a real-world browsing and YouTubing. Earlier you saw me actually break out a chart that showed you the performance of these three laptops in battery rundown, running UL Procyon Office, which is, again, a very repeatable. It's a great benchmark. I love it. Again, you're getting 10, 12 hours on that. I run it more than a dozen, almost 24 times on those laptops over the last month and a half, and very, very repeatable. It's a great benchmark, but I would say it's also not necessarily realistic as a test either, because there's other things that you do at the same time. If you actually go back to my Snapdragon X video, you can actually see where I talk about the methodology here. I'll summarize it quickly. Basically, what I do is I take all three laptops, I hook them up to a Huntech Sync Monster that lets me control all three laptops using the same mouse and keyboard. So what I did is I fired up Chrome 127 on all three laptops. I'm running all three laptops in the basically out-of-box power state, recommended and balanced power for the x86 laptops, and recommended for the Surface laptop with the ARM chip inside of it. And for the entire run, this is very painful. I just sit there and I browse. And I browse, and I browse, and I browse. And I know a lot of people have their own browsing tests. They have their own scripts. There's a lot of stuff I've tried out there. They're cool stuff. This is quite a bit different, I think, because I think a lot of scripts that I've seen in the past rely on a single browser tab. I basically, for this browsing test, I tried to make it as realistic as possible. So I really did. I fired up Chrome. I fired up YouTube. I started listening to the Full Nerd in the background, and a lot of people do this. And also, by the way, I used earphones to minimize the impact of the speaker subsystem on the consumption of battery life. So I'm using, the same Apple earbuds on all three of these laptops, and essentially doing the exact same thing. So if I go to PCWorld.com and I click on the top story on all three of those laptops, that story would be clicked on as though I were sitting in front of the laptop. And I think it's basically about as real as you get. And then again, a lot of these pre-canned benchmarks where they use browsing might use that same tab, tell that tab to go to another website. Well, I don't think people browse that way. I think a lot of people start new tabs. I started a new tab. I go to Macworld. I started a new tab. I go to the SFGate. I started a new tab. I go to Wikipedia. I open new tabs, new tabs, new tabs. I get up to about 25 different tabs. I can read you the list here, but I also made it as realistic as possible because logging, a lot of the browsing logging tests I've seen basically sit there and artificially scroll down the page at a fixed speed. I actually force myself to read through these pages as much as possible. If I got bored with something and I wanted to do something else, I scrolled down fast, or I went and did something else, or I opened up a new tab, but I did not just continue to scroll down the same page to the bottom and then scroll back up to the top. So it is about as real world as you can get, in my opinion, because, again, this is something I did realistically. So there were quite a few times I would listen to the Full Nerd in the background, and then there were times where I had to take a break because simply I could not sit there for the amount of time that it would be to browse, because that's just painful. So I would do something very realistic, I think, as I would go to a full screen. I would run the Full Nerd in full screen. I'd make sure that they're all set to the same res and they were all at the same res. By the way, this is all on Wi-Fi 6 router, an isolated access point that I placed about 6 feet away from the laptops themselves. And I basically had, if I needed a 20-minute break or a 30-minute break, I just watched the Full Nerd in full screen mode, which basically simulated what a lot of people do, because, hey, I'm watching a live stream, I'm watching something, and I'm doing that. So I would consider this probably Again, it is not real world because I'm doing it for artificial reasons, but about as close as you can get to the real world as you can. I did not do what I did in the previous testing on the Snapdragon X versus Meteor Lake because it takes quite a bit of work to create fake accounts for every single thing and set everything up to make sure it runs the same way. Believe me, it is very difficult. And the other problem with this test is it is an organic test. You cannot reproduce this test. Nobody can reproduce this test. I can run it once and that's it. And that is a big weakness of the test, but it also does tell me what is actually really realistically achievable by these laptops. And by the way, all of these screens were set to 200 nits on all of these, which is a realistic brightness. That actually works quite well in my dining room table. Even in the daytime, I didn't crank it up to max brightness. I didn't crank it down to 100 nits or 150 nits. 200 is quite usable on these laptops and does save you a little bit of battery life. The winner, as you can see, is that 78 watt hour ZenBook S16. That's giving you what? 1, 2, 3, 4, 5, 6, 7, 8, 9, just about 10 hours of browsing and YouTubing, as I would call it, because I don't call that streaming, I call that YouTubing. So just over 10 hours for that Ryzen AI 9, which is pretty respectable. Yes, it does have that big old 78 watt hour battery, but it does also have an OLED panel. And I did run the ZenBook 14 and the S16, ZenBook 16 in dark mode, but there are simply some web pages that ignore being in dark mode. Wikipedia, for example, ignores it. There's quite a few web pages that simply ignored it. So I would consider it quite a mix. PC World ignores dark mode. You do get a power-eating white background. Again, please stick around for that OLED comparison IPS because it's going to be an eye-opener. Snapdragon comes in second, solid second, I would say, with what? 1, 2, 3, 4, 5, 6, 7, 8 hours. So just over 8 hours versus just over 10 hours for that Ryzen AI. Yes, the Ryzen AI has a bigger battery, but it has the OLED panel. But, Snapdragon X Elite is quite efficient, does quite well, and that's no surprise. It's really not bad. It's really respectable, and you've seen that already proven in that power consumption test measured at the USB-C port. Meteor Lake loses here. ZenBook 14 OLED with Core Ultra 155H with 75 watt hour battery coming in at what? Let's see, 1, 2, 3. Just over 7 hours. Again, not bad though. I would say not bad to get about 7 hours of battery life on this doing realistic browsing. And, Meteor Lake actually does quite well. It would have been nice to throw in a Raptor Lake laptop to compare this to. Maybe one day I can do it, but again, I can max out up 4 laptops with the setup I have. But I think if I were to do this, I would want to do this with an Apple M3 or an M4 and a Lunar Lake laptop because that's what I'm more interested in to see a Raptor Lake. And I do want to point out that the ZenBook 14 OLED is at a little bit of a disadvantage. This laptop we've had since January and we've been hammering on it with testing, and the battery is in not a great shape. And now currently the max it will charge up to is about 68 watt hours. So I recorded the actual battery capacity that it had charged up to before the run started. It was 78 watt hours for the ZenBook S16, so it was a fairly fresh battery. The Snapdragon X Elite, 54 watt hours. But that Core Ultra with that Meteor Lake has had its battery beat on its quite a bit, and we're seeing about 10% less battery capacity in it. I've tried a couple things to try to get it to come back to 100%, but I haven't been able to find it yet. Maybe it's something the UFI I've got to dig around at, but I just want you to consider that that laptop is at a disadvantage because it has a 68 watt hour battery, not a 75 watt hour battery where it starts, and it has an OLED. So just remember that. Let's keep going though. Hey, you know what? Again, Gordon keeps harping on OLED. I keep hearing Gordon talk about OLED. Yeah, he keeps talking about the OLED. Why does that matter so much? I think that 78 watt hour battery being 44% larger than the Snapdragon X Elite matters the most. Well, to get to the bottom of that, I wanted to see how much OLED matters because I will say I've seen a lot of OEM numbers already and they say like, hey, the laptop with IPS, especially the 1080p IPS, awesome battery life. OLED's still pretty good, but you're going to take a big hit. So what I did is I took these laptops and I hooked them up to an external USB-C powered panel. It's a very small panel, but it was USB-C powered, plugging into HDMI on both of these ZenBook laptops. So basically, and that let me disable the OLED panel on the ZenBook S16 and disable the OLED panel on the ZenBook 14, as well as the Surface Laptop 7. Results, voila. The first number you see is the original number that you saw for running Office Procyon 365. Again, I ran this because it is very, very repeatable on all of these tests. And we're looking at, again, 635 minutes for that ZenBook 14 OLED. If I take that OLED on that ZenBook 14, though, and I turn off the panel and I run an external panel using HDMI, I double the battery life. It gets up to 1,223 minutes on OLED. Yes, I'm not making this up. This is insane, right? We're going from 635 minutes with the inboard panel to an external OLED, external panel of 1,200 minutes. So basically doubling the battery life if we turn off that OLED. And I know you're going, well, that's insane, Gordon, because I'm not going to run it on battery without using the inboard panel or something, because that just makes zero sense. It just doesn't make any sense. And I agree, but what this is designed to do is give you an idea of just how much OLED can suck up power. And again, remember, UL Procyon Office runs the entire time with a white background practically. So it eats up a lot of power on OLED. And I don't know what the wattage ratings of these panels are. They're both Samsung panels. I've been digging up. I've been trying to find the numbers, but I haven't been able to find it. But you're looking at a significant power consumption when you're running them at 200 nits. Again, this is all at 200 nits, and also running them with white background. So OLED on white is not great. We've known this for a long time. I didn't realize how significant it can be. And these are fairly high-res panels because you're looking at 2880 by 1800. I don't know if that matters or not. But still, clearly OLED is going to consume more power, especially with a white background. Up next, though, in orange is that Surface Laptop 7 with the Snapdragon X Elite. That has a sharp IPS panel. It's 120 hertz. All three of these are 120 hertz panels. They're all touchscreens as well, which does use a little bit of power for the digitizer. But you're looking at 2304 by 1536 res on the Snapdragon. Well, of course, the weird thing is you're going, well, you must have these charts mixed up. No, I double-checked it because I thought I did too. But I actually saw a performance rundown decrease when I ran the internal panel off. And I know you're going, well, that makes zero sense, man. You must have screwed this up. Well, I'm telling you this is correct, and I have a theory on that, and that is because the ZenBook 14 and the ZenBook S16 both have HDMI ports. And I decided to run basically the HDMI ports because if you're running a USB-C panel over USB-C and it's got touch on it, which I do have on this, it can get a little weird sometimes. So I decided to run an HDMI mode on both of those. And because the Surface Laptop 7 does not have an HDMI port, and why you didn't do that, Microsoft, I don't know. There's plenty of room on the side of the laptop. I had to run it in USB-C mode. So I ran it over USB-C, though, using HDMI. So I ran USB-C to an HDMI adapter. So the panel was running in HDMI because I did not want that touch panel to activate on my touch screen because I did not want that to eat the power up. But still, why in the world is running external USB-C to HDMI using up power? Is it the adapter I'm using? Possibly. Possibly that's it. And the other thing that I'm also really thinking it is when you are plugged into USB-C or the USB 4 ports on pretty much, or a Thunderbolt port, frankly, on any laptop, you basically light up that Thunderbolt port. You light up the chips behind the Thunderbolt port. If there's any redrivers, retimers in there, you light those up as well. I don't know how much power those chips consume, but they do consume power. And it's possible that was just enough to drag down the battery performance of the Snapdragon X Elite in the Surface Laptop 7. And I think that's likely the reason we saw a decrease in performance of these laptops when running that way, because it makes no sense. But honestly, it's got to be the only reason. So I'll have to go back and run the others just to see over using USB-C to HDMI to see how much power. But this is This is a passive USB-C to HDMI adapter. It's hard to believe that there's anything in there that's using a lot of power, but it is a possibility, and both of those combined may have dragged it down because I did have to run it slightly differently than I did on the other two laptops. And again, we look at the bottom in red, ZenBook S16 with the Ryzen AI 9 HX and that 78 watt-hour battery. And of course, I screwed this up as a 78 watt-hour battery in that laptop. We go from 642 minutes to 1,695. Yeah, we go from 642 minutes to almost 1,700 minutes. That's just simply insane. And it again points to, that's a 16-inch OLED. It's 2880 by 1800. It's pretty high res, and it's got touch in there. And that panel, when you're running it, basically lit up all the time because you're running near white almost all the time in UL Procyon Office. It's probably can consume quite a bit of power. So I can imagine if you had one of these laptops and they built it with an IPS panel, you actually would see probably a pretty decent increase in performance and battery life. That's my guess. And we'll probably see that broken up by some of the OEMs to decide like, hey, I want a laptop with IPS because I want to have something I can market with, X amount of hours, right? It's also possible they're going to use that to market the laptop saying, oh, by the way, we can get 12 hours of battery life for 15 hours of battery life. But anyway, would I take OLED over battery life? That's the big question. Because honestly, the fact that it is using a 78 watt-hour battery and you're getting still exceptionally good battery life out of this. You're getting basically equal of that Surface Laptop 7 with that Snapdragon X Elite in it. Yes, it has a quite a bit better battery life in it, but OLEDs are just gorgeous. And I would say a lot of consumers that can go and they're looking at stores like, this laptop gives me 12 hours, this gives me 10 hours, but I can get an OLED. I think a lot of consumers are going to go, give me that OLED, because OLEDs are plain sexy. But that's just something you need to know because that is important information for you to know. But anyway, that is a very eye-opening thing because clearly panel technology has a big thing to play here. Let's keep going, though. Okay, this is performance. This is why, and I'm really remembering why I included this. So I saw a very sharp drop-off in performance for the Ryzen AI 9 HX370. Yeah, I got better battery life, better battery life in Meteor Lake, slightly better than Snapdragon X Elite. No, wait. It got decent battery life. Let's just say that. I can't remember that because that was 6 slides ago. But it did that at the cost of performance. Unplug the S16 on running in balance mode. It does actually, ASUS does try to push it into battery. They try to push it into best battery, or let's see, what the heck is that? They try to put it into battery conservation mode. I can't remember what the exact name of it is in the Microsoft Power mode, but I decided to run it recommended to equal because it would be the same as the Meteor Lake, and frankly, most Windows x86 laptops will run basically in balance mode. They will not fall all the way back to the battery saver mode, basically, because you're giving up a lot of performance there. In fact, this performance would have probably been even worse if I cranked it back. So I want to dive into this a little bit more to look at it because performance does matter. When you're running on battery, it does make quite a bit of difference. So what I did is I took Geekbench, and I took Geekbench 6.3 and I ran it on the laptops, plugged into the wall, AC. Yes, I know, all laptops run on DC. Electrical nerds, I know, but this is the way people understand it. And I also ran it on DC, so unplug. AC is plugged in, DC is unplugged. And you can see when we're running in the best performance mode, so I basically selected best performance mode on all 3 laptops, and also on, by the way, for the 2 ASUS laptops, you can actually select fan mode. I selected, I think, standard fan mode for both of those. I didn't select the high performance fan mode. And you basically see that we see the performance drop off to what we're looking at on. I'm going to make sure I don't screw this up. We're seeing it's not bad. I mean, you probably would not feel it. You're looking at a multi-core drop off in performance for Ryzen AI 300, about 12%. For Meteor Lake, about 6%. Snapdragon doesn't care. Doesn't care whether they're plugged in or not when you set the best performance mode. Then in the next mode, though, is better performance, because that's the middle mode that is available on the laptops, on the Snapdragon-based laptop, the Surface anyway. The Asus x86 laptops, both the S16 and the ZenBook 14, give you the choice of balance. So running on balance, though, and again, the fan mode set to standard, we see that the Ryzen drop off 24%. So basically, you're going to see multi-core performance on in Geekbench drop off about 24%. And I pick Geekbench because it is a fairly easy test to run. It is also fairly lightweight. It's not like Cinebench that takes 20 minutes to run. So it's actually probably reflective of a little more realistic concerns than somebody running Cinebench realistically, frankly. Meteor Lake actually falls off the most, giving up about 28% when you unplug it and you're running in balance mode on battery. So give up about a third of your performance on that ZenBook 14 OLED laptop. And again, Snapdragon X does not care. So that is again something that is in favor of Snapdragon, right? So let's move on though. What's my next chart? Okay, this should be the last chart. And this is a single core performance. And again, you can see the performance of these laptops. It drops off again on the x86 laptops. We see Ryzen in best performance drop off 11%. Meteor Lake we see drop off 3%. In balanced mode, we see Ryzen AI 300 drop off 29%. We see Meteor Lake give up 34%. And we see Snapdragon not caring. It does not care, unplugged or no matter what, on better performance and best performance. It basically runs full tilt, running Geekbench this whole time. That may not be the same with the heavier load, but on Geekbench, single core, and also multi-core, it doesn't care. Let's go back and take a look, because look at all those orange lines are damn near the same. Yeah, it's a little bit of a trend down, but you're just not going to feel it. It's just simply going to feel snappier in everything you do. Whereas, those x86 laptops are going to feel a little bit slower than than they were plugged into the wall. And on the last one, when you're looking at set to best efficiency, yeah, there it goes. That's what they call it. If you actually have the Windows power mode set to best efficiency, we see the Ryzen AI 300 give up 20% performance, and Meteor Lake give up 29% performance. And again, we actually do see in recommended mode, the default mode for Snapdragon X, that ARM chip, it does fall off from better performance or best performance, but that's just simply the power mode, because it does not care whether it's plugged in or not plugged in. And I would consider this a big win for the Snapdragon X Elite over the x86 parts, because that is quite impressive. So overall, though, what do I think? I think in raw performance plugged into the wall, again, go back and look at our Ryzen AI 300 video for that. Ryzen AI 300 is currently top of the world. There are some things it can give up some performance against Snapdragon and Meteor Lake. And of course, Meteor Lake, when you're talking about a higher TDP part, 55 watt hour, 45 watt hour parts, it probably can pull up ahead of it, but that is a hotter part. And you really should be comparing to a Ryzen AI 300 at a higher wattage setting too. So Ryzen AI really is top of the world when you're looking at performance plugged in to the wall. Also, battery efficiency is quite good compared against Meteor Lake. Meteor Lake just is not doing quite as well against Ryzen AI 300 as you hope it would. We saw plenty of things where it was just simply consuming more power. And then for actually battery runtime, again, that gets really, really squiffy, because we got OLED, we got size of battery here. I haven't gotten there yet. Maybe if I get matching laptops, we'll see. We'll find out one day. But as a science experiment, I'm going to guess Snapdragon's probably going to give you better battery runtime than both x86 parts. We'll see. Maybe. I don't know. If you have the same laptop with the same screen, same battery, maybe. That's my suspicion. But I do think probably Ryzen AI x86 versus Intel Core Ultra Meteor Lake, both x86 chips, both basically probably what most consumers are going to be considering buying because they do want that compatibility. They want that everything is going to work on my laptop. They don't want to deal with that incompatibility of Snapdragon. And that is something that is real. Please go look at my Snapdragon X to see the kind of problems I ran into trying to run Surface Laptop 7 on Snapdragon X ARM with things that just didn't like it. So that's a real concern. So I really do think a lot of consumers are going to go, I want x86 still. So give me that x86. And between Ryzen AI 9 and Core Ultra, winner in raw performance is Ryzen AI. Efficiency also, I tip the hat to Ryzen AI, although probably not quite significantly depending on the test. They actually run fairly close sometimes, but definitely Ryzen AI is the leadership there. And if you're running simply plugged into the wall and you want plugged into the wall and unplugged performance, the winner, of course, you should probably go look, at least consider a ARM-based laptop because running Windows, because they are worthy of looking at, unless of course you have compatibility issues, because that does matter. So yeah, I'm sorry there are no easy answers because basically, and I'm not doing this to make you watch it. You need to watch part 2 here. You need to watch part 1 of Ryzen AI, and then you need to watch our Snapdragon X video because we get into all the power consumption and performance of that laptop there. And then again, we know Intel's got Lunar Lake coming. I have high expectations of it as well. If you can wait, probably a month or so, maybe we'll see the chip. Maybe you can buy it for the holiday, and that's the way to go because you're going to get your, claimed great x86 compatibility. Everything's going to work. You're going to get, basically awesome ARM-like efficiency, and maybe we'll get great efficiency on the different power modes too, because it does bug me that unplug the Ryzen AI and the Meteor Lake on those, default settings of or balanced will nerf the performance so much. But anyway, I'm sorry you got to do your homework. If you're going to be buying a really nice, expensive laptop, one of these beautiful laptops with their OLED panels, and oh yeah, OLED between OLED and IPS, I probably would go for OLED, folks. Those OLEDs are just simply beautiful. Those high-res OLEDs are just to die for. And with these big batteries, you're really not giving that much up in overall battery runtime. So that's my opinion here. Anyway, there's more videos to come. You can see those on PC World's YouTube video. And, of course, go to PCWorld.com for all your best PC coverage. Look at it's crazy. It's Ryzen AI 300. That OLED performance is nuts. I'm shocked. I'm actually legitimately shocked.